Thank you. So, hello everyone. Sorry for this small delay. So, there's logistic problem. So, my name is Walid Daboubi. I'm currently working at Richemont in Geneva. I'm heading the group security analytics. And today my talk is not related to my work at Richemont. It's like a personal project called Tornado. And it is an implementation of human-in-the-loop machine learning. So what I will try to go through is the use case of Tornado for low-cost manufacturing data labeling. So through this presentation, we will have a quick reminder about data-centric AI or machine learning. From that, we will talk a bit about human-in-the-loop machine learning. Then, as an implementation of human-in-the-loop machine learning, we will talk about Tornado AI. We will, after that, talk about the manufacturing use case. We'll have a small demo. We'll tell you how to use Tornado and how to contribute if you are interested to. So to explain what is data-centric machine learning, maybe the best way is to have a reminder about the general machine learning. So you have as an input data. It can be historical data with labels. You will have the phase when you are asked to train your model, fine-tune it, etc. And the last phase is to put this model in production. So traditionally, while doing this training, we are focusing on the model. So it is a model-centric artificial intelligence. So we are doing tuning, regularization, optimization. We are evaluating the model, going through several iterations after choosing the last one. What we mean by data-centric artificial intelligence, which is a trend term in the last few months, is to also focus on the data part of the model training process. So as you can see, we are like spotting the light on the data. We are trying to enhance quality. We are cleaning further the data we are feeding to our algorithms to train the model. We are trying to augment the data, transforming it. So this is what we mean by data-centric AI. But in practice, I would say that the data-centric AI is like a collaboration between the traditional model-centric and the new or relatively new data-centric artificial intelligence. So it is more to take more care about the data when going through the training process. From here, we can talk about the human-in-the-loop machine learning concept. So human-in-the-loop is a kind of data-centric AI. So it can be used for different objectives. So for example, labeling data, the thing that we are talking about today. It can also be used for reducing biases in data, for example. And it can also be used as part of fine-tuning models and training models. So as you can see here, we have 4 steps. The first one is like we have our original data set. Let's suppose that this data set is not labeled in this case. We will take a part of this data set randomly. So let's say 10% of this data set. We will send this data set to like a human expert about the matter. He will label this data. And with this portion of labeled data, we'll train a model. So we call this model a learner because it's not our final model. So it will be a basic model that we will use to label the remaining part of the data. So as you can see after step 4, so we have the model that will be labeling the remaining part of the data that we haven't labeled in the beginning. After that, we will send like the prediction or the labeled data to the human expert, who will correct the labels that was done by the learner. And we will repeat this process. We will have different iterations until we reach the desired confidence or certitude of this model. So this is, in a nutshell, what is human-in-the-loop machine learning. So from here, we can talk about Tornado AI, which is a very simple implementation about this human-in-the-loop machine learning. So the data flow of Tornado is the following. So we start with a raw data set, like here, like in the human-in-the-loop basic machine learning process. This raw data, it can be structured data, it can be text data or image in the current version. We will send this data to Tornado, which is web-based, collaborative, and user-friendly tool. And our goal is to have labeled data as output. So this is from data flow point of view. From user workflow, so we start, the first step is to sign up or to log into Tornado. We can create a project, and when creating a new project, we upload data, or we can take like an existing project and work on it. The next step would be the HITL iteration or the human in the loop iteration. So we'll go into all the iterations described here. And our goal is to have the labeled data in the end. Here you can see the screenshot when we are like taking a zip that is containing image data and labeled image data. So we just upload it to the application. Here in this example, it was used for the Data-Centric AI competition. That was a competition organized by Andrew Ng several months ago, I guess in July or June. And it is like containing NMIST like Roman numbers. And the goal is to label those numbers like the traditional NMIST data set. So the next step, Tornado will load the data from the zip file we input. The next step will tell us that we have successfully downloaded our data. Next, we can start like labeling the seed as described in the human in the loop process. So to do this, we need to select threshold and a data size. But in the beginning, when you are starting a new project, we don't need this threshold because we don't have any labels and any probabilities yet. So here it was the screenshot was taken from another project, but in the beginning, we'll just need to select the seed size. After that, we will have user interface where the user will put the manual labels, as you can see here. So he's labeling this number in text. As you can see, you have the human label part. And after labeling here we have selected 50 data units. After this, we will click on auto label, which will train the learner or the small model that we will use to label the remaining data. So from architecture point of view, Tornado AI is based on the following. So you have, for the machine learning part, very classic. We have Keras, sklearn, and all of this is running with Python. For the data part, we are using Elasticsearch for storing the data because we have different types of data, so we need to be the most flexible possible. For the image part, so we are storing the path of the image in Elasticsearch, but the image themselves can be used in S3, for example, or in like a hard drive. You have the possibility to plug Kibana to like make exploration of the data, go through it, etc. And the last part is this user interface, which is based on Rails application. So the user interface is like the contact point of with the user, and it is like it has small database to manage the users since it is collaborative tool. So, for example, I can start a project, and my colleague can take over that project, and we can like work on the project as a group, and all of this is managed with the Rails part. From operational point of view, so it is managed with Docker and Docker Compose, because as you can see, you have different tools here. You have Elasticsearch, Keras, Rails, etc. So we have a Docker Compose, and it is very easy to install and in your like own infrastructure and just start using it. So now I will try to go through like small demo. It is like it is a video in YouTube. I don't know if you can do this. I'll try. Oh, sorry for this.
Data is transforming the business landscape, just as it is transforming social systems.
So for this demo, as we are talking about manufacturing data labeling, so I take data from Kaggle, from a data set called metal casting data. And so I uploaded, so it is, in the beginning, it is like a labeled data set, so, but I considered that it is not labeled for this test. I loaded this data set into Tornado. So here you can see that the user is adding the human labels. So for example, here it is about propellers, if it is okay from quality point of view, he's saying okay. If it is defectuous, he will just say defectuous, so it is like binary classification. As we don't have a lot of time, I will just progress a bit on the video. So here, he will continue labeling his seed. Here, I think it is 100 data unit. And at this point, you will click on auto label. We'll start the labeling. Here you can see that the status of the dataset is saying labeling. And after a while, we will get like automatic labeling arriving to all the dataset. So as you can see here, so the first like iteration, of course, it will not have a good quality because we are like training with 10 data unit or something. So it is very small data set for training. But at this point, we can go through more iterations. And as we go into iterations, the data quality will get better. So as you can see here, we have in the chart for every iteration, the accuracy, validation, and the training accuracy, the confidence, the mean confidence, the max confidence, and we mean by confidence the probability of prediction. So here is doing another iteration. And after several ones, we will get in our charts all the iteration we went through. So here, after 2 iteration, we can see that it is not it's not that very good like quality. So after several iterations, the quality will get better. And as a last step, the user will be able to download his data set. So he will click just on download, and he will have a file with all the image files, paths, and their labels, actually. So that was it for the demo. So here you can see like the loaded data with labels, starting with totally labeled data. So let's go back to the presentation. Sorry for this. So yeah, in order to use this like tool, you can just go to GitHub, clone the repository, and after that just like run the Docker compose. So if you will have your own infrastructure, even in local computer, it will be able to run. For the moment, we don't have SaaS. So for example, the demo I went through, it was hosted at AWS just for testing, but we can have a SaaS with multi-user, etc. If you have ideas and you like the project and you would like to contribute, you can just fork the project from GitHub. add the feature and like just send a pull request, that would be very welcome to if you would like. So yeah, that was it concerning Tornado. I don't know if you have any points to share or any questions. Thank you.
Any questions?
Maybe in that case, I have one. So what do you see as the next steps for that tool? Because you have like a first good basis, but then I guess you want to expand it maybe.
Exactly. So that was in version 3. But that's fine. Actually, yeah, for me, I think that we will need to do more code refactoring and quality enhancing of the code. We also need to, the next step, like as a feature, will be to be able to download the model as a package, so it will be usable with APIs. So just download the zip and it can be deployed to be used for, in this case, for quality inspection for manufacturing. So yeah, and maybe make it available as a SaaS, as I said, but that needs some money. So yeah, that's the top 3 priorities, I guess.